How's it going again, ladies and gentlemen? It's Johnny here, looking at 24.4 questions, starting to get into electromotive force and calculating voltages and all that good stuff. Number one, which are the following most likely to be a good oxidizing agent? Well, you got to remember that oxidizing agents get reduced. So it's really asking which one of these things is most likely to be really good at getting reduced. Well, we know alkaline metals like to get oxidized, so it's not going to be that. Alkaline earth metals also like to get oxidized. Halogens, those group 17s, they're nonmetals. They love to get reduced, so C's looking good. Lanthanides, types of metals, transition elements, metals, they more, the best ones to be oxidized here, definitely the halogens. The reduction half reaction occurring in a standard hydrogen electrode is, so reduction half reaction with hydrogen. So you know you're going to start with H plus because it can be reduced to give you H20. So you're going to have two H pluses, gaining a total of 2 electrons to give you H20, right? Which would be a gas. Cool. That's it. 3. The more blank the value of E0 reduced, the greater the driving force for reduction. This is just kind of a, forget there's a word for it, where you just kind of choose positive. Convention, right? So convention is the more positive, the more likely it is to react. All right. So we got some half reactions here with E0s, and we're going to calculate the potentials. So the standard cell potential for the voltaic cell based on the reaction below is blank. So we look, what's happening to Sn plus 2? It's becoming Sn plus 4. So we find that reaction, hey, I found it here, but it's the opposite. So if the reaction that we're having is the opposite of what's on the chart, we just take the opposite sign of that number. So we know, well, potential for that happening is negative 0.154 volts. And then we look, all right, well, Fe is becoming, going from plus 3 to plus 2. So we're looking at this reaction. And its voltage is 0.771, positive. So you add those together, you combine those, and you get beep bop boop 0.617 volts in the positive. So that could be used to make a voltaic cell. You got a positive voltage there. 5. Standard potential for the voltaic cell based on the reaction below is blank. So again, you're looking CRs. Let's go from CR0 to CR plus 3. I found the opposite of that reaction, so I'm going to have to take the opposite sign of that potential. So it would be positive 0.74. What's happening to iron? It's going from plus 3 to plus 2, so I'm using this one, so it's positive 0.771. And the 3 here doesn't change its likelihood to be reduced, all right? The coefficients can be ignored when you're calculating the voltages. So it's just 0.771. Combine those numbers. What do you get? 1.51 volts as your answer. 6. Standard cell potential for the voltaic cell based on the reaction below is blank. So again, chromium goes from 0 to plus 3. So I found the opposite. So I got to take the opposite sign. So it's going to be positive 0.74. And the iron's going from plus 2 to 0. So I found it right here. And I'm just going to use that same sign because it's the same reaction. So I get positive 0.74 and negative 0.440, and they combine to give me a positive 0.30 volts. So that's just how you do it. Right? 7. Standard cell potential for the voltaic cell and the reaction below is what? So I go, Sn goes from plus 4 to plus 2, so I find that reaction right here. It's the same as in my reaction, so I just use the same sign, positive 0.154. Chromium goes from 0 to positive 3. I found the opposite reaction here, so I got to use the opposite sign, positive 0.74. Combine those numbers and you get positive 0.89 volts. Right? It's not the most difficult stuff. All right. True or false? When the cell potential is positive in a voltaic cell, the cell reaction will not proceed spontaneously. That not is not correct. So that would give us false. If it wasn't for that not, if it said reaction will proceed spontaneously, it'd be great. But negative would mean it doesn't occur spontaneously. Positive means it will. 9. Standard reduction potential, E0 red, is proportional to the stoichiometric coefficients. That is false. Remember, you can ignore the coefficients when you're doing this. When you're doing the voltages, ignore them. And 10. Standard reduction potential for X is 1.23, and that of Y is negative 0.44. Therefore, X is reduced by Y. That is true. So these are reduction potentials. This likely to be reduced. Y, since it has a negative voltage, it's more likely to be oxidized. So Y is going to get oxidized and X is going to be reduced. That's it. Cool. See you in class. Bring questions.